In this video using the unsteady state wellbore simulator, USWS, we're going to predict for a well producing water the pressure at which gas water loading occurs, that is, the water is so much that the gas cannot lift the water to the surface and the well will stop flowing, and then to use an inner string for gas lifting the water in order to maintain production of the well. We go to data file builder of USWS, and we're going to open up a previously created data file. And in this data file, I would go through some of the features of the data file. It's a black oil PVT data. We have gas and water properties. So we've got the formation volume factor of gas, gas viscosity, and formation volume factor of water, and water viscosity. The oil values are not used in this particular example because we're dealing with a gas water model. So in the trajectory for this well, we have used a fairly few number of segments in order to capture the entire pipe trajectory in one screen. Otherwise, we would have to scroll down, keep on scrolling down every time we change the screen. So just for the purpose of this tutorial, I've restricted the number of segments to 27 segments just for the display purposes, and use 100 feet for each segment. So this is about a 2,500 feet deep well. And for this well, with this number of segments in pipe data, I've created a tubing of 4.5 inch and divided the tubing in time 0 days from 1 to 1. The pipe OD ID, if I use this in inches, I would say pipe OD is 4.5 inches, about ID is about 3.9 inch. Roughness, perforation fraction, correlation, oil water saturation, initial pressure, left eye blank. Diameter of solid tubing, there's no solid tubing in this case here. A reservoir dimension around the size of the well just for calculation of PI, the permeability of 1,000 millidarcies. And extended that to 726 with the same parameters. And the 727, the bottom of the well, I'm going to use the same pipe diameter and roughness, but perfect so that it is connected to a reservoir at that particular segment. So we are flowing at the bottom of the well, water flowing in, and initializing the well at 1,000 psi at that segment depth. The program will calculate the initial tubing pressure all the way up the pipe, and the same saturation, so it's all gas. There's no oil, no water, it's all gas. And we're going to display a schematic just to show you how it looks like. The schematic is basically one single straight tubing with reservoir influx at 727, and production of well will be up the first segment. So in this very simple test model, we're going to see the effect of the gas water loading on this well. The reservoir data is spaced out in intervals of 0.5 days. What we're doing is we're saying that at 727, the bottommost segment, the reservoir pressure is 1,000 at 0 days, and we're modeling the decline of the reservoir pressure with time. In actual fact, the reservoir pressure will decline depending on the size of the reservoir and the volume produced. But here we're simulating that decline by saying that every 0.5 days, we're going to drop the pressure of the reservoir by 50 psi, simulating a rapid decline. This is because we do not want to run this model over a number of years or however long it takes to deplete the reservoir, but to see at what pressure level this reservoir would start to have gas water loading problems. So we're running this up to 6.5 days and dropping the pressure from 1000 in steps of 50 psi down, in this case, up to 350 psi. The pipes are the reservoir is initially filled with water at 30% and gas saturation 70%. So in this case, we are not varying the saturation as a function of reservoir depletion, but just dropping the reservoir pressure itself. Though in other cases that you work on, you could change the water saturation, simulating an aquifer influx, in addition to a reservoir pressure change drop. A PVT table number 1 that we just referred to here, and initial saturation pressure of 3000 that was also in this backward PVT table. A relative permeability table of 1, so that is referred to in this here, and just straight line curves. In this case, straight line curves. And we do not allow a pipe to backflow into the reservoir. We do not allow that. So this is for increasing the speed of the run, for not showing the oscillation when flow goes in and out of the reservoir. You're just saying that as soon as the gas water loading occurs, the well is going to shut in and build up a water column in the pipe, not flowing out back to the reservoir. For production injection data, we have specified at time 0 days, 1 production point at pipe number 1, segment number 1. So only 1 pipe, 1 segment, at top segment, a point flow coefficient of 100, offset pressure of 300 psi, no injection of fluids, and with no limitation on production of fluids either. So no production of fluid limitation, no injection fluid limitation, just an offset pressure at 300 psi. So we can go back to the general form, and we're going to run this up to 7 days. So because our production reservoir data goes up to 6.5 days, so we run this 7 days, and we're going to get outputs. We're going to use a minimum time step size of E minus 10, a time step size starting at 1 E minus 7, a maximum time step size of 0.01, output every 0.1 day. So we're going to have output 0.1, 0.2, 0.3, and output interval after that for every 0.1 day after the output interval. Have our first restart record right at 0.1 days. So this completes the data review for this particular case. I'm just going to close and save the data set. And this is the name of the data set that I've chosen. It's a test outer pipe 4-inch, reservoir volume variable, water saturation 30, initialization of pipe, gas water loading. Save that file. And if I close this form and go to run data files and select that case to run, which was this one here, and run the case, it's going to run, and you can see the time step number, step size, the model time, stop time, and running, and it's going for 5 days. It's slowing down a bit here, and we can stop at 7 days for the run. So when the run is finished, we'll click on this, and this will be the file of interest. Open the results, and we can type data, pressure, select the results. We can look at water saturation, gas saturation, water rate, gas rate, all times, and select this output and go to output time. Next times you can see the water saturation in the pipe for each of the segments, 27 segments, the water rate flowing in, the gas rate flowing in, and this is not changing for every 0.5 days. 0.5 days. So we can actually go in and select every 0.5 days. You can just get every output time. And look at the next time, 0.5 days. Next time, 0.5 days, water rate, gas rate. Next time, and you can see the rate is decreasing as the reservoir pressure decreases. So I select the report and add in the reservoir cell pressure. And the reservoir cell pressure is here. And next time, you can see the reservoir cell pressure dropping. And until it goes to 5 days, and at 5.5 days, or 5 days, once it changed to 500 psi, the well rate stops and the water head forms, liquid loading happens, water loading happens, the well stops flowing, and we get a head of water. So this implies that at the reservoir pressure of 500 psi for this particular configuration, we cannot produce gas and water at the wellhead pressure of 300 psi. We need to resort to gas lifting. So let's try a case whereby we put in a inner pipe. So exit, and we're going to open up an inner pipe case where we're taking the pipe data and we've added an inner pipe of 2.5 inch ID. We have specified from 1 to 25 the segments of this OD and ID. Left the initial pressure saturation is blank, so this is a gas filled pipe. In the last segment 26, we have specified initial pressure of 1,000 psi. So the program is going to calculate the wellhead pressure, the segment pressure from 1 to 25. And the last segment is open the flow to the outer pipe. So if I display the pipe schematic, you can see here that I now have a schematic. I have an inner pipe, and that inner pipe is open the flow to the last pipe. So I'm going to produce up the annulus. So in the reservoir data stays the same. Production injection data is producing only from pipe 1, the annulus of the pipe, segment 1, and we're just going to close that file and run that data file. So we have saved the file already. Previously I've done that, and the file is saved as this name here, and I'm going to run the case. And when after it's run, I'm going to it's running, it's almost there, it's almost 7 days, but it's okay. So it's finished running, and I'll open the results of that run. Auto pipe, inner pipe, open the results of the run, and get the last use report selection. Click on second pipe 2, and we can see here now that the flow is through the annulus of the outer pipe 1. There's no flow in pipe 2 because there's no off-take point, and it's 100% gas in there. The next time, and so on, and we can get the rates of the well. And now we see that up to 6 days, up to 450 psi, using the inner pipe, is restricted the flow in the annulus and extended the flow time for flow off pressure to 450 psi. So after 450 psi, the well stops flowing, and we have a water head built up in the pipe. So now we can add in a gas lift into this pipe here, and I'll just show you the data file. and gas lift at 6 days. So in 6 days when the well died, we're going to add gas lift simply by adding a production injection point, a pipe 2, the inner pipe, point number 2, pipe number 2, segment number 1, injection pressure 500 psi with a maximum injection gas rate of 100 mcf per day. So at 6 days, we're going to add in gas lift gas injection to maintain or carry on producing this well. So if we were to close the file and run the file, I previously saved it as this file name here, gas lift 6 days. Open that file and start the run. And now we hope that with the gas lift, we're going to extend the run beyond 6 days when the reservoir pressure drops below the point where water loading starts. The run is finished. If you open the results of this, click on here, open the results of the run, and get the last use report selection, and look at the results of the run. Next time, until 6 days. At 6 days, we introduced gas lift gas. Previously, at 6.5 days, we were unable to flow this well, but with the addition of gas lift gas flowing down the inner tubing at 100 mcf per day, coming over here and being produced with the reservoir gas, lifting this water up the wellbore, we're still able to extend the production for a period of time. And after 7 days, we cannot, before reservoir pressure 400, 450, 400, 400 is unable to get production, so the well has loaded up again at a lower pressure. So we may need more gas lift gas. We may need more gas lift gas than 100. So if similarly, if we took this data set and made that gas lift gas, say 200 from safe. I tried 300 before, so let's try 300 from safe data file, and we're just going to ignore the error message, that warning message, and save it at 300 and save it, run it, and create the run. And we're going to see if the additional gas lift gas, we can extend this run, we can extend the life of the reservoir longer than previously without the inner tubing and the gas lift injection. So if you open up that results file, get a last use production, and go to 7 days. If you go to 7 days, 6.5 days, previously we were unable to flow up to 7 days. This time we are able to flow up to 7 days using a higher gas lift gas rate to lift the water in the well. So this movie shows a gas water loading example with gas lift gas helping to lift the water when there's not enough reservoir pressure to help lift the water up to the surface. Thank you for your attention.